Hello and welcome back to another episode of From the Field. I'm your host, Casey Orr, broadcasting from Wellington, New Zealand, I should say. And I hope everyone enjoyed the previous stream, where I believe had good chemistry on it. And we're actually talking about a subject I actually quite love. I took chemistry into decent form. Unfortunately, not smart enough to do it at university, although I think it's college's high school for the North American audiences and the world that's been under the British influence, I should say. So from here, I do have Deepika with me, which is an amazing guest. It's going to be sharing her knowledge on modern application observability. Do you want to do a quick intro, Deepika?
Thanks, Casey, for having me here. So, hi everyone. My name is Deepika Kumar, and I'm an ISV solution architect here at AWS New Zealand. And I primarily work with software and digital native businesses, help them building and deploy the AWS solution securely and on AWS cloud as per the best practices. And prior to AWS, I was working as a solution architect with Vector New Zealand and at Riyadh, a five-trend company, helping them digital transformation, SaaS journey, etc. So I'm excited to be here and talk about this topic of the observability, which I'm hearing from most of our customers that sometimes it gets really difficult with monitoring the modern applications. So looking forward to it. Thanks, Casey.
Yeah, distributed systems are a special type of HUD when things go wrong. And I was also saying earlier that your background is looking very intellectual. It's making me need to invest in some form of display because it's looking looking very bland.
Yeah, that is the thing. But yeah.
Cool, awesome. Moving on. So last week we did the part 3 for how to become a network ninja, which was resiliency. So if you haven't seen that, or if you're following that series, do go back and actually watch it in the VODs. Next week we have part 4, which is best practices. I believe the host for that is Miriam, which is another one of our amazing local essays that it's within the networking TFC, and she has a very rich and vibrant background in networking. So with that, I will say let's jump into it. Deepika, do you actually want to have a quick overview on which the topic and like what people can expect to see throughout the stream?
Yeah, so I'll just give a quick topic as the slide says that there are not too many slides. I'm just covering in just 5 slides, but we will be talking about that how you can solve the hardest problem of observability in modern applications. So the idea here is that what I'm seeing with my customers and previously my workplaces, we were building, and these customers are building the modern applications, which are great. Usually they are built off serverless or the container-based architecture, and it gives you the flexibility that you can decompose the larger applications or your monolith into a smaller applications, which means that each component can scale individually. And it also gives your developers an agility to build and deploy faster. However, it comes with a very interesting challenge of observability. And what I have seen that my development team at my previous workplace and with some of my customers, developers are spending quite a lot of time troubleshooting that what's happening in their applications, where the issue is, because each component is independent and autonomous, and you are chasing the logs into different systems and different components, and which and I we were hearing lots of complaints around that how they can make it easier to understand what's happening inside the system. So today's topic we will be covering that how some of the AWS services like X-ray and what other mechanisms are there to make this observability piece easier, and you exactly know what is happening in the system and where the issue is in near real time.
Yeah, in my old company as well, we had similar issues because we had quite a distributed system, and race conditions were a thing that we had to keep a constant eye out for. And it
Yeah.
led to doing the same thing, building out an extensive observability layer.
Yeah, and I am seeing that this is quite a pattern with number of customers now that the observability is becoming very important. So maybe in my next slide I'll talk about it, that why it is important, and having observability mechanism in place, it helps your business grow faster, operational excellence, number of benefits you can get through it. So let's get started with it. So to my next slide. So since we are talking about observability, I'll just spend a minute on that what observability is. So usually when we talk about observability, it's a measure of how well you can understand what is happening inside your system, usually done it through by instrumenting your system to collect metrics, logs, or traces. So for example, if I give you an example that 90% of your method in your service completes under 500 milliseconds or 300 milliseconds, how's your APIs are responding, how well they are responding in terms of integration code status, integration response, what are the status code, how many requests are getting successful, etc. So there are a number of different measures you can get through the observability.
Yep, and a lot of people will be saying that this sounds awfully a lot like the monitoring frameworks that already have in place. What's the difference between monitoring and observability, and like why would you need both?
Yeah, that's a very good question, and I usually get asked this question number of times that customer says that they have got monitoring mechanism in place. Why do they need the observability? So maybe just I'll explain it with an example here as well. So when we talk about monitoring, it just tells you when something is wrong in the system. So usually when I see the customers have got monitoring mechanism in place, let's say their CPU utilization goes over 90%, then they have some alarm set up, or that is, we call it monitoring, which tells you whether the system is on or off, or you can say that whether the system is in good state or error state. But when we talk about observability, I think it is somewhat more than monitoring. It tells you, it provides you the visibility inside the system, that how a request is performing, how the request is flowing throughout the distributed system, and then it provides you the visibility and the real time troubleshooting on that. So when I say about an example, so if I'll just take a simple example here, let's say you are running an e-commerce application which is dependent on a third party service for the payment services, and your users comes to your website, adds the product to the cart, and they do the intermediary processes like adding the product to the cart, shipping, billing, and finally they are on to the checkout step. And then the final step during the checkout, the request fails. And that's where you would like to understand that why the request has failed, what is happening inside the system, and what are the influencing factor that request is not going through. And that's where monitoring is just not enough to tell you that where the issue is. And that's where observability comes into the picture. So if you don't have the right observability mechanism in place, it can impact your customer experience, because here you see that the customer has done already spent 5 minutes on this and the request did not get through. So it will provide a bad customer experience, and subsequently it can impact your company revenues because the purchases are not able to make, and then it takes for your developers quite a bit of time to understand where the issue is and then troubleshoot that issue. But if you will have observability mechanism in place, it it is quite simple. You know exactly where the issue is, and that can be solved quickly.
Monitoring also quite often will trigger automated responses where observability won't.
Yeah, so with observability, it's like I can cover it with we have got few services. It provides you to the real time view, and that's where you will go to specific to that service and just know that where the issue is. And but observability is like it collects, like when I say that it's a logs, metrics, and traces, which combines all of these things together. So I'll cover that what observability is built of. There are few pillars to the observability, so which you just covered, Tracy, here. So when we talk about observability, we talk about specific to these pillars, the logs, metrics, and traces, and we combine all of these together, and which provides the observability here.
Well, you've gone over the tooling here, but like, what is good practice for observability? Like, what would be a good place to start for someone that is like unfamiliar with it?
Yeah. So maybe I haven't covered the tooling properly here. So I'll just go through logs, metrics, and traces, what tooling is available. Then I can cover that what sort of best practices organizations or some of customers are doing, setting up a good observability practice in the tool in their organization. So the first pillar of the observability is the logs. So I'm not going into the tooling at the moment. We really need to understand that what exactly these pillars are. So when we talk about logs, you can think of logs. It says it is really important for debugging and troubleshooting the applications, and especially for your development or your support team. And for logs, it needs to be sequence aware. So you need to ensure that logs are entering into the right order so that your engineering team, they can reproduce or replicate the issues. Then the second one is matrix, which is, we sort of cover it. You can think of it's a time series representation of the data for your application performance, health, and the business data over the period. Again, this is very critical. Like if you want to know CPU utilization, memory, disk, IO, that's where matrix helps. And the X-ray, X-ray is the service. Then traces, you can think of it's a record of an end-to-end user journey, how a user request is flowing through entire distributed system and presented back to the user. And it tells you exactly how the request is doing, how well it is doing, and if there is an issue, why there is an issue is. So there are different tooling, like CloudWatch is a tool. You can use CloudWatch logs for the logging. CloudWatch Matrix is available. Traces is there. Again, there are some partner solutions are also available. So you can use different tooling. So Trace, Casey, coming back to your question here, you mentioned about how can the tools are there, that how can an organization set up a good observability practice. So I'll just take an example of my previous workplace, what we have done there, that there are few observability tenets which we have followed. So the first one is that all observable systems should emit events in the form of logs, matrix, and traces. And this is what exactly I have done at my previous organization, that we were collecting the CloudWatch logs, setting up the custom matrix, or you can, CloudWatch supports the basic metrics, but we wanted the detailed metrics in that scenario. So you can set up the detailed metrics, you can create your custom ones. And then for end-to-end visibility, we use traces because the SaaS service which we were building is quite distributed. So traces was the service where we helped in gathering the data, that how the request is performing. And the second one, I will say that all components in your distributed application or modern application, they should be instrumented. So sometimes what especially into the enterprise organization, and when we didn't have that much capacity, what we were seeing that we were cutting the corners when the service was not critical, which is like a true monolith architecture. But what we have seen with the modern application, that having a black box in the system, it made it really difficult for our developers to troubleshoot where the issue is. So this is really important. Though the service is not critical, you make sure that you are instrumenting all of the components. And the most important thing, the third tenet, is that instrumentation should not be hard to do, or because how you get the principle to in practice by following the third principle, that make the instrumentation as easier as possible. And how you usually do to make the instrumentation easier, just there are some tools available, like you can use open source projects like open telemetry. There are some AWS services which we were just talking about, you can use that. Or you can do some of the organizations, like they were created their own innovation projects like auto instrumentation, and which is like you insert that auto instrumentation part, it automatically starts collecting that data. And if you heard about Lambda Power Tools, so case if that's the thing, if you can also, if you are using Lambda and you want to include the observability in there, you can just include Lambda Power Tools, where you add the Lambda layer in there, and that instrumentation is done automatically there.
Yep. Just a quick question. Outfit 313 has also asked about the availability of these services within the regions. So X-ray, I have actually just checked while like while Rebecca was finishing up what she was saying, and X-ray is available in Ireland. It should be available in most regions because it's managed to get into US GovCloud, what generally is the last region to get most things. So it has been moved. It used to be its own standalone service, and now you will find it under CloudWatch itself. Um, and on the left-hand side, it will you'll see X-ray traces, and there'll be service mapping traces.
Yeah. Thanks, Tracy. And I think we will cover all these things into the demo as well, that how you can access the service. So in the next few slides, we'll see that as well.
Awesome.
So these are the observability tools from X-ray. I think Tracy has explained about X-ray a little bit here, that again, it's a managed service. You don't have to do the heavy lifting of correlating the traces into different systems or components. We do it for you. So all the heavy lifting is done by us. You just use X-ray as a managed service, and it provides the service maps and traces. So if you think about X-ray, you can think it as a data platform for your developers. So the developers can use it just to simply understand that how their application is doing, what is happening inside the application, and why your application is performing in such manner if there are some issues in there. And on top of that, X-ray also provides the analytical capability. So you can put the filters and few things in there, and you can figure out that if the request is performing weird for a specific user or a specific item type. X-ray also provides the capability around that as well. And the one of the beauty of the X-ray is that it is cloud agnostic. So if you can run X-ray on your co-location or your on-prem servers as well. So you just need to put the X-ray agents, which collects the traces from your workloads which you are running on-prem and sends it to X-ray, and where all the correlation things is done by the X-ray itself, and you can have a graphical representation of that, how the request is flowing throughout the system, which I will cover into the demo as well.
From my experience as well, X-ray is a really good starting point if you haven't really started with observability before you deep dive into any of the more advanced tooling that's out there, because you have whole companies built around this concept, and their tooling is very, very in depth. But this is a really, really good, cheap, and quick and easy starting point, so you can actually start playing around with it, experimenting with it, fixing where the pain points are, what works for you, what doesn't work for you. So when you do want to step up and actually go full hog into it, then you you don't have to experience all that pain while also experiencing pain in other areas of your business, such as the CFO coming at you. And in that regard, because everything, this will probably going to require some code changes. So what does that look like?
So it depends on the service, which you are using here. So let's say if you are using an Elastic Beanstalk or a Lambda, so for that you can use the language-specific libraries, or X-ray provides the X-ray SDK, which you just need to include in your code, which will send the X-ray data to, which will send all the calls to the different service to the X-ray. And if you are using, let's say, container workload, then you will need to install the X-ray agent on your container, so which will tell you that if there is an issue just with the container or the fleet, just with the cluster or the fleet of the clusters there. So for that, you just install the X-ray agent there, and then you instrument your application in a way which sends that metric data, traces data to X-ray agents, and where X-ray agents will buffer these requests and then send it to the X-ray, and that's where it will be presented to the service map. So, and other thing is here is that X-ray is automatically built in to Lambda and the API gateway, which I will show you into the next slide, that how you can enable that. You can do it via console, or you can do it if you are using infrastructure as a code like Terraform or CloudFormation. You can set up, define that parameter in there, and then X-ray will be automatically enabled for that. But however, with that, you won't get much data around that. You will just know that, yes, this is a service. But if you want the detailed information, like if your Lambda is running a custom code or a machine learning model, your Lambda is running. So you might need to know that where the issue is that. So for that, you will need the instrumentation there. So you just have to have X-ray SDK attached to your code, which I'll show you later on in the code, and then which will start collecting the data in there.
Awesome. I think that it'd be
Mhm.
easier just to actually have this slide up
Yeah.
because this explains a lot more in detail.
Yeah. So
Um,
the on the slide, I think you'll just say that how X-ray works. So there are three main concepts of X-ray. One is traces, segments, and the subsegments. So you can think of trace as that application centric end-to-end request, how the request is originated from the user side, how the request is traveled through different segments like S3 bucket, API gateway, Lambda, and then presented it back to the user. So trace is like end-to-end user request. And then the segment you can think of, it's essentially a chunk of individual service. So like API gateway or a Lambda, that's an individual service. You get the data that, okay, this is a service initialization or the cold start of the Lambda, or if you are, that's the segment. And then we call it, there is a notion of subsegment. So when we talk about subsegment, you can think of, it's essentially in the service, but it's a remote call to another service. Let's say your Lambda is writing an item to the DynamoDB, or getting an item from DynamoDB, or putting the uh, message in the SQSQ. You can instrument it in a way that you can gather information from that specific code, that how long that request takes, and present it back to the user. With X-ray, there is another quite an important thing. Let's say I mentioned about, if you are interested, if you have got a issue just for a specific type of request, let's say a specific item type, you are having issues with that. With when you are instrumenting it, it allows you to add the annotations in the code. So let's say you just add the annotations of that specific item ID. So you can query on that, okay, for my item ID X, what's the issue, why the issue is happening. You can add that annotations on that. So you can think of annotations as like sort of user defined or system defined metadata about that request on that. And you can also add the metadata into that if you want to drill down into specific segment or subsegment in there. I have got that part built into the demo, so I'll focus on that, how that works in there. And I think I covered about X-Ray SDK. It supports different languages like Python, Ruby, .NET, Node.js. But this is available on our documentation site. You can see that which languages AWS SDK support in there.
and Starus asked about, can I use X-ray with multiple apps? Sorry, can I use X-ray with apps I can't? Apparently, I can't read. Using multiple platforms like EC2, ECS, and Lambda. The answer to that should be yes.
Yeah. For Lambda, it's just, I will show you for EC2 and ECS. As I mentioned earlier, you just need to install the X-ray agents in there, which will start and instrument your applications just to collect the data, and then X-ray will automatically send the data to the X-ray backend, and that's where the correlation and the trace ID is all done by AWS with us.
I don't think we actually touched on the multi-account aspect of X-ray, because generally a lot of our bigger customers especially are using the multi-account strategy with control tower, etc. How does that look like with X-ray?
Yeah, so for this is doable. So when you install like X-ray agents and include X-ray SDK, it can assume roles. So through that, you can push the data from one account to another account quite easily.
So that would allow you to have a centralized
Yeah,
observability account for operational.
that's correct, Tracy.
Awesome.
So that is around X-ray concepts and how observability works. So now it's a time to a quick demo. So for demo architecture, I'm just using a serverless application where my customers are going through an API gateway, and I've got few Lambda functions in here which get all the items from my DynamoDB table, get item by ID, and a put item function. If it is successful, it posts on SNS topic, which notifies there is another Lambda for the notification on that. So just to for the ease of the demo, what I have done here, I have deployed two services. One service without instrumentation, where I have just enabled the X-ray tracing on API gateway and Lambda. And the another one is where I've done detailed instrumentation, where I'm adding annotations and the metadata. And then we'll see that with X-ray, how through the instrumentation, how much detail you can get into that. So let's start with a quick demo here. Any questions, Casey, on the architecture?
Mostly just around situations where there's high latency for a
Yeah.
specific type of request.
Yep.
Like,
Sure.
does X-ray help with identifying those?
Yeah, so for that, I think what you can do, you can define the filter expressions or create the X-ray groups. So let's say if you have got higher latency for a specific user, you just put the filter expression, and then you can run that analytical capabilities that give me all that requests where the latency is high. I think I have built that into the demo, so I'll show you that how that works in there.
Awesome. And you can also you can query on annotations from memory.
Yes, that's correct. I'll take you through to that via the demo when I'm doing that, how we can do.
Also, can the viewers confirm that the text is big enough for you to read?
Yeah. Uh,
I'm assuming it should be good, but just continue on. I'll let you know if anyone asks for it to be zoomed in.
yeah. So just for that demo, I'm just using the Cloud9 IDE here. So let me just give me a clear thing. Okay, give me a second. So before I go into just the demo, I'm using the YAML file, how I do SAM template, how I deploy that code. So for when I see for the first application for the sample app, I have just enabled the tracing here for the Lambda. That tracing is active. And for API gateway, I have enabled tracing, enabled is true. By doing that, it will start collecting the trace on that specific request to that. So this is a put item function. I'm not doing much here. It's just a simple function which is writing it to the DynamoDB for sample application. That's where not much of the tracing is enabled. And let's run that query. Give me a second. I have written down these commands. So let me just export my API name. So the first request, what I'm doing here, I am getting that all the functions, retrieving the item where the item ID is 1 and 2. And the second request, which I will be performing here by the put item number 5 and 6. So just to note here, this is a simple application where I haven't done the instrumentation at all. So how do you access X-ray here? So you do go to the CloudWatch. In CloudWatch, when you will go, you will just see X-ray traces here, as Tracy explained earlier. You go to the service map. It gives you an option to go 5-minute, 15-minute, 30-minute intervals. You can set up your custom interval here. So it shows that in last 3 hours, I had these requests. So let me just pick last 5 minutes. As I mentioned that it is near real time. So if you look at here, it shows that the request is originating from this client, goes through to the API gateway and goes through different lambdas and how it's presented back. And if you pick up these arrows here, it shows you to the distribute response time. And if you pick up the nodes, it just give me a sec. Let me go a little bit bigger.
The increase in text size.
Yeah. Does it look okay? So when you select the node here, it tells you all the matrix, which is a dashboard, latency, how many requests, how many faults are coming. In here, there is no fault rate. And then the important part is here that for this node, you can analyze the traces. So let me go here, analyze the traces here. Oops, sorry. I'm just so look at the view traces here.
Yeah, it's kind of annoying that the view trace doesn't open up in a new window.
Yeah.
Like, I am definitely going to tell the service team about that.
Yeah, so as Tracy was mentioning earlier, that you can see that these are the traces which comes in last 5 minutes. Before going into the traces, I'll just give you a bit of overview on here that you can have, as Tracy was mentioned, that you can put refined query by. So there are different options available. HTTP method, let's say if you are interested into just get method or post method, you can put it in here. If you are interested into a specific client IP or the user agent, it gives you an options to there. Another good thing is that the availability zone as well. So that is a good feature of X-ray, that it also helps you that how different availability zones are performing. So let's say if you are running into multiple AZs, X-ray also helps you to do that, how different AZs are performing in here. With this sample application, I haven't added the annotations at the moment. Instrumentation is not here, so you won't see much annotations is here. These are the system annotations which are automatically in here. Now let's go into our trace details. So if you look at these traces, we made the two requests of get and two requests of post subsequently. So for the first trace, if you see, the duration is 1.82 second, and for the second request, it is 0.0777 seconds. And you would like to know that why it's the issue, and we know that it's the lambda thing. It's the cold start lambda. When we talk about lambda, the cold start is always there. So similar to the post request as well. So let's just jump into these two traces. Again, if you go into that, it just tells you onto the top what is the method type, what is the duration, and it tells you the whole request in here. That so now if you're coming into the lambda, it shows you to the initialization time, which tells you that's the cold start time here. And if you click on that, it just gives you an option to annotations and metadata. You won't see in this service because we haven't added the metadata and the instrumentation here. And the second one, if you go onto the second request, a subsequent post request, there is no initialization time as compared to this, because this lambda is already warm and it did not take any time onto the cold start time. So that is the simple application where not much instrumentation is done. Now look at the example where another service where I have done added the instrumentation. Let's look at the code that what I have done here. So this is on,
Just
sorry.
before you jump into that, does it also track the IAM, the role that was being used?
Yep, it should be. I can show you into the lambda. Just give me a second. Yep, it should be here. Response code, duration, resources. Yeah, here's the function ARN. Give me a second. I have to give me a sec. Sometimes it is function ARM resources name. I have to check on that, Casey. It's usually into one of these things, and I
It'll
know
probably be
it's.
under Lambda. I'm assuming it'll be under the Lambda one.
I'm into the ops. It's the put item function lambda region.
So good. We'll track it down later. We'll find it as
Yeah,
we.
yeah. It's either one of these on that. So that is around the simple application. So now if you look at this, my second service, that's where I have added more instrumentation in here. I have added X-ray SDK, which is capturing all the service call made from this Lambda function. And there here, what I'm doing, that I'm wrapping that function code into a subsegment and closing the subsegment over here. And into that subsegment, I'm just adding the annotations of your the ID of the item and what is the status, whether the request went through success or the failed. And the similar thing happening onto the uh, put item function went onto the DynamoDB, again adding it into, wrapping it into the subsegment and adding, closing the subsegment. And during the DynamoDB call, I'm adding the metadata as well, that what are the parameters are passed to that request. And similar thing I'm doing into the get item by ID function. So adding the subsegment here and getting more details in here. So let's run some of these commands and then we'll see that how it performs for the second service. Let me just clear that and copy. I'm just running the whole. Let me just get all the items here, run a few more requests. Another one is, let's say if I'm interested in just these item 1 and 2. I have already 4 items in there. And just do a put item operations here. Okay, so we have done few of the operations here. So the another option is that you can go to the service map, refresh it, and it should show you another stack. Give me a sec. Sometimes, yeah, that's the reason. So now if you see for my second service, if I select a specific node and go to view traces again, it doesn't open it to different window. And you will see that we made the 5 requests. One is the get, another get request, and the post request. Similar to that, the previous one, the Lambda cold start, the first request, you will see the duration is quite high. The second one is quite faster. Now let's look at how the request is performing and what extra details which we see here as compared to the previous ones. Yep, so that is 3 point. So if you look at that by adding the instrumentation, having the right instrumentation, if you go into the put item lambda function, this is the lambda cold start time, which shows you a little bit more details in here. You won't see the metadata here. Then it shows you invocation. And then into the handler function, you will just see that the annotations which we have added in here, what is the item ID and what is the status of that request. And then this handler function is keeping the additional call to the another put item data, which is a DynamoDB function, and then publishing a new item to the SNS notification in here. So if you look into here, you will see we have added all these metadata details in here. So the metadata details are added over here. And if you will go specifically to the DynamoDB, it just tells you that how much request it is taking, 859 seconds, and additional details are in here. So if you look into that, it tells you to the whole path, how the request is flowing through the Lambda, notification Lambda, and comes back to the user. And the total response is in 3.7 seconds. And then similar to another request, if you look here, you won't see the initialization time because the Lambda is already warm and the similar information is in there, and you can deep dive into that where the issue exactly is. Now, Casey, you have asked that filtering and those capabilities. So if I coming back to here, let's say if I'm just interested on a specific item ID. So these are the user annotations are added in here. So let's say if I am interested in only an item ID where the item ID is 5, I just add it into the query and run the query. It just says you that for item ID, this is the post request has been made and what is the response time. It's looking like that. Another thing which you could do here, let's say if I am just interested into just the post method, and I'll just say add that to query, and you will just have the data around that. in terms of your some of the user requests, where you will just say that where the response time is greater than something, or response time is less than 2 milliseconds. For the demo purpose, I have already created a filter group where the higher latency is greater than 2, and it just tells you. So let me just take out this from here and run query. It just tells you, did I do some mistake here? Uh, Give me a sec. I did some mistake. Service ID. There is one extra. Give me a sec.
Brackets always get the best of us.
Yeah. Yeah. So you just see there are two user requests where the response time is greater than 2 seconds, and you will get those requests. And so how you create these X-ray groups. So for that, you simply need to go to the settings in here, go CloudWatch settings, go to the traces, and go to the groups, view settings. You can either create new group. So let me just show you, edit this group, and that's where I have set up a new group. It automatically creates that what is the resource name and what is the filter expression you want to give. You can save these queries for your analytical teams, and just to analyze that how the requests are doing. You can do more things over here. So that tells you around service map. See, it's just more than 5 minutes. So let me just go 15 minutes, and it just tells you that in 15 minutes what services have been called, how the request is flowing, and specifically if you're interested, you can go to these details. Another thing it provides, X-Ray provides you the dashboarding capabilities, where you can go to the dashboards. It shows you that what is the latency is looking like, how many requests are coming, what faults are in there as well. Actually, I missed to cover one thing over here. So when you look at the service graph, service map here, uh, the good thing is that if you have got some requests which are not going through error state, it does the color coding in you. So let's in this we did not have any issue. So in last 3 hours, if you look at this is color coding golden, which tells you that there is a one request with the errors. So it does the color code. If there are fault, there will be the red color in here. So it just provides a good graphical interpretation that where the issues are in here. It also have an option here that where you can select the nodes. It can be the icons, or you can put the matrix in there, that what is the average response time, and these things are looking like in here. So you have an option there how you could do these things here. So that is mostly about the demo. Any other question, or if you want to look at few other details in here?
And just a question from me, which you might not know off the top of your head, but
Mhm.
I know that a lot of with businesses I interact with, they'll use external tools such as Grafana or anything like that for their operational tool set. Can you export this data from X-Ray and have it visible within like a custom dashboard?
So for Matrix, there is a tool called Prometheus. So for that, I don't think so. You can use it for you can use it for traces. You can use it for logs and Matrix. But if you are interested into traces, I have seen a number of my customers are using OpenSearch for that. So OpenSearch is you can bring the logs, Matrix, and traces to OpenSearch, and then you can have QuickSight on top of that to build your own dashboards in there. And QuickSight is a tool which you can embed into your web applications, and your team can have license to that. So for the dashboarding, yeah, through QuickSight and OpenSearch, you could do that.
And OpenSearch and Grafana in that case, since it's
Yeah,
that.
Grafana is yeah, OpenSearch. Yeah, Grafana can be used too. A number of customers are using Grafana as well for the visualization layer. Yeah.
Awesome. Is there anything else that you wanted to cover off in this demo before we?
I think most of the things I have covered in here. Is there any other question? Yeah, feel free to ask me. Yeah.
Um, it there's comments around integration with like VS Code.
VS Code integration with
X-ray. There wouldn't it
uh,
wouldn't really make much sense for my end.
yeah. Yeah, I'm thinking if it is around your IDE, then yeah, there is a different service like Code Catalyst you can use. That is an integration with VS Code, but X-Ray, I'm not able to contemplate that how it can fit with VS Code
Yeah. Oh, for debugging purposes.
for debugging purposes. I have to look into that. Uh, for debugging, I think you'll use CloudWatch logs like that. I have to look into that. I'm not 100% sure, but yeah,
Yeah, there's yeah, generally yeah, observability is happening, but you're looking and caring about what just happened, right? And you're not
yeah,
really in your IDE. You're kind
yeah,
of using you kind of using that to give you an indication of where to look in your IDE.
yeah.
But it'd be kind of cool. Like I know that you have like psychometric complexity, like plugins and stuff like that, that give you the amount of like decisions that's happening in that one method. It'd be cool if there was like a plugin that could actually take and go the error percentage of a certain method. That'd be cool.
Yeah, that's a cool idea. Yeah,
And then that would kind of mean that as a developer just going through doing their like normal day to day, they'll see something in method 10 red and they're like, oh god, I'm
yeah,
working late today.
yeah. Maybe I'm just thinking that with our AI tools coming on, like Code Whisperer and those things, might be. Yeah,
And you never need to feel bad about asking any type of question. Asking questions is how we all learn. Like a lot of the time, I ask myself stupid questions. Well, actually, at the end of it, nothing stupid. But
yeah,
you'll be surprised what you can accomplish.
yeah,
Cool. While we wait for if there's any other methods that, oh, not methods, sorry, geez. Apparently, I am really struggling with English today. While any other questions come through, I do want to say that next week, same time, we have part 4 for how to become a network ninja. So that is covering off best practices. So last week was resiliency, and the week before that was connectivity, and the week before that was foundations. I don't think the first two are on Twitch anymore because they have aged out. And then with that, hopefully, like you've learned something around observability and you give X-Ray a try, or if you just want to actually know more about it, then feel free to reach out to anyone within the AWS like sphere of influence. We're always happy to help. And thank you, Deepika, for taking time out of your day to come and share your expertise on this.
Thanks, Casey. And I'll tell that the networking one, I watched the last session. It was a great session from Ruskin. So do watch the next networking series. Quite a wealth amount of knowledge there.
Yeah, a lot of effort's been put into those
Yeah.
shows, so it really, really shows.
Yeah.
Not that you didn't put no effort into this one, but that's like one of our flagship series for the year. And with that, I will say I don't see any other questions coming through, so I will end it here. Everyone, hopefully, have a good weekend and have enjoyed your Anzac weekend, the weekend prior, if you was in Australia and New Zealand. And yeah, thank you very much for watching us, and hope to see you next time. Masiwa.
Yeah. Thank you.